All right, so pay close attention here, guys, so we can go through this. So for question number 1, okay, we have Mars Express, okay, that's orbiting Mars. Okay, we have the mass of Mars given to us. Okay, so 6.42 times 10 to the 23 kilograms. Okay, we are given Mars's orbital radius, which is 3.40 times 10 to the 6 meters. Okay, we're told the mass of Mars Express. Okay, so that'll be 2.78 times 10 to the 2 kilograms. Okay, and it's at an altitude of 4.5 times 10 to the 5 meters. All right, why am I given two different distances? Because they both add up to the radius. Okay, the orbital radius, or any radius that we use in a gravitation problem, is the distance from the center of one object to the center of the other. Okay, so we have to combine those two things in order to get our full radius. Okay, so they can have a mark here. Okay, we're trying to find the force of gravity between them, so that's not going to require any manipulation. It's just going to be big G times the mass of Mars times the mass of Mars Express divided by the radius of the orbit, okay, squared. All right, so they can have a mark for that. Okay, we do need to calculate that actual orbital radius, so that'll be 4.5 times 10 to the 5 plus 6.42 times 10 to the, plus 3.40 times 10 to the 6. So we're going to get 3.85 times 10 to the 6 meters as our radius. Have a mark for that. Okay, so to calculate the force of gravity, okay, we're going to plug in our numbers here. So that'll be 6.67 times 10 to the minus 11 times 6.42 times 10 to the 23 times 2.78, or 278 we'll just say, and divided by our 3.85 times 10 to the 6 squared. All right, so our final answer there for the force of gravity . 3.85 6 squared. All right, so our force of gravity there should be 803 newtons, but we have only two significant figures here, so that's going to be 8.0 times 10 to the 2 newtons. Fourth and final mark for that. Okay, questions on that one?
You need a direction towards this.
No, it's between them, it's mutual. All right, for question number 2, all right, we have this asteroid, or these two asteroids. Okay, we know both of their masses, so we'll say mass 1 equals 1.40 times 10 to the 15 kilograms. That's a 15. Okay, and our second asteroid is 2.5 times 10 to the 17 kilograms. Okay, we're looking for how far apart they are. That would be the radius if the force of gravity between them is 3.7 times 10 to the 8 newtons. All right, so 1 mark for Gibbons. Okay, 1 mark for force of gravity equals big G times mass 1 times mass 2 over r squared. We have to manipulate. I might put the squared up there. R squared. Okay, we have to manipulate that for r. So that's going to mean r equals the square root of big G times mass 1 times mass 2 over the force of gravity. Basically, we're just switching radius and force of gravity, and we have the square root because radius is squared. Okay, so they can have a 3rd mark for that, or maybe they went straight to plugging in the numbers, which would look like this: 6.67 times 10 to the minus 11, okay, times 1.40 times 10 to the 15 times 2.5 times 10 to the 17 divided by 3.7 times 10 to the 8. Right. Okay, and then we got to square root that. Okay, so the distance between them is going to be 7.9 times 10 to the 6. Meters for their fourth mark on that one. That's the right number, sig digs right, number 2. All right, questions on that one? 4. They're both out of 4. Okay, so if you can give them a mark out of 8 at the top, and then bring them up to me.